guys, this is lesson 11.4, using similar triangles. Triangles that have the same shape but not necessarily the same size are called similar triangles. So a really quick way to know if a triangle is similar or not, you just need to make sure all their angles match up. So if you notice the picture down here, we have 65, 95, 20. 65, 95, 20. Since they both have the same type of angles, the same exact angle measurements, we know they're similar. The length of their sides doesn't matter. We just have to make sure we know that all the angles inside are the same. So one quick study tip that will help you out a lot is if two angles in one triangle are congruent to two angles in another triangle, then the third angle is also congruent. Okay, so I'll come back to this when we do an example. So on this first example, it says tell whether the triangles are similar, and then we have to explain. So on this first triangle, we're going to say, okay, let's figure out what is x. So 75 plus 50 plus x is 180. I can then solve and combine my like terms and then subtract to get x equals 55. Now that I know that x equals 55, I know this angle right here is 55. But watch, that means they have a 55 and a 50, and a 55 and a 50. So based on that study tip that we just read, we don't have to check anymore because two of their angles match up. If two angles match up, then the third one is definitely going to match up. So just to be careful, we can check the next one, but again, you do not have to. We put y plus 50 plus 55 equals 180. Combine your like terms, subtract, and get 75. So that means this one right here is 75. So now we know they all match up. So the triangles have the same angle measures, 75, 50, and 55, so they are similar. Okay? Let's do another example. We have two triangles down here. Now the box in the corner identifies that it is 90 degrees. So you can set up a similar equation, x plus 90 plus 42 equals 180. So we combine like terms and subtract, and we get x equals 48. So we know this angle up here is 48. So let's see if we have two to match up. We have 90, 90, and wait a second, I don't have a 38. I have a 48. So maybe I did my math wrong. We can do the next triangle. 90 plus 38 plus y equals 180. Subtract 128. I get 52. They do not match up at all. So the only thing they have in common is the 90. And since that's the case, the triangles do not have the same angle measures, so they are not similar. All right? Your turn. Go ahead and try number 1 to see if they are similar. All right, if you did number 1 right, you would have found out that yes, the triangles are similar. But if you didn't get that, let's go over the process. So on this first triangle, we can set up the equation 30 plus 122 plus y equals 180. I can combine my like terms, 152, and then I can subtract to get 28. Well, that means this right here is 28, and I have 1, 2, 1, 2. Two of my triangles match up. Well, since two of my triangles match up, I don't have to check what x is because I know x will be 30. If you want to check for it just to make sure, you can. So the answer is yes, and we can explain it by saying the triangles have the same angle measures. Go ahead and try number 2. All right, number 2. If you did this one correctly, you would have figured out that no, they're not the same. So let's see the process. 52 plus 40 plus y equals 180. So 92 plus y equals 180. So y equals 88. So all right, 40 and 40 match up, but 88 The other one has 86. So right off the bat, since two of the angles do not match up, you can say, no, the triangles have different angle measures. Now on this next part here on your worksheet, they don't have an example for it in the book, so I'm going to do number 3 with you. Number 3, it says the triangles are similar, so find the value of x. If we know the triangles are similar, we know all the angles will match up. So this will be 20, 20. That means this one has to match this one. So right off the bat, I can just say x equals 105 degrees. It's as simple as that. You just need to figure out what angle matches with what angle. All right? Go ahead and try number 4. All right, if you solved number 4 correctly, you would have gotten that x equals 55. Well, if you didn't get that and you thought it was 35, then I want you to look at it really carefully. This side matches up with this side. Therefore, this angle here is 35. So we're trying to figure out what is this angle. So this is where x would be. So you can think of swinging this triangle around like that. If that's the case, then we just have to solve for x. That means we have to do 90 plus 35 plus x equals 180. So 125 plus x equals 180. So x equals 55. Now, indirect measurements uses similar figures to find a missing measure when it is difficult to find it directly. What does that mean? Well, we can use similar triangles in the real world to find different measurements or different information that is just too hard to find on its own. So here, you plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. So you measure different things. A, explain why triangle ABC and triangle DEC are similar. Well, we have to look at the information. The only way we can tell that they're similar is if two of the angles match up. So we're going to look really, really closely and notice, okay, this and this match up. They're both 90. But we don't know anything else. So what do we know about angles that could help us figure this out? If you look really carefully, you might just see that this line crosses with this line. Since they cross like that, I hope you notice they're vertical angles. Well, if they're vertical angles, we know they're the same. I don't even need to know what the measurement is. I just know they're the same. So that means two of our angles do match up. So the book says angle B and angle E are right angles. All right, we got that. And angle ACB, which is right here, and angle DCE, which is right here, are vertical angles, so they are congruent. So that's exactly what the book did. Since they're congruent, and here it says because two angles in triangle ABC are congruent to two angles in triangle DEC, the third angles are also congruent, based on our study tip we learned at the beginning of the lesson. So the triangles have the same angle measures, so they are similar. Now we get to use those to just make a proportion. So the ratios of the corresponding side lengths and similar triangles are equal. Write and solve a proportion to find x. So x, this side matches up with this side, so x over 60. And then 40 matches up with 50, so 40 over 50. Then you can just do cross products. Here they multiply by the denominator, but you could do cross products. And you solve and get x equals 48. All right? So the distance across the river is 48 feet. And that's actually kind of hard to measure. I don't have a measuring tape that goes 48 feet, and I wouldn't want to do it across a river. On your worksheet, we have a similar situation. We have two similar triangles. They tell us they're similar, so we don't have to worry about it. And we have to figure out, how tall is this tree? I can't measure it, so I'm going to use similar triangles to figure it out. Okay, hopefully you identified that there's a little triangle right here, and then the whole thing is the big triangle. So we can make a proportion. I'm going to do x over 4 will equal the length of the entire triangle, 15, over just the little one, 6. That gives me 6x equals 60. So the height of my tree is 10 feet. That's the end of the lesson. If you have any questions, please let me know.